Good morning, class. Am I audible?
Yes, sir.
Am I audible? Okay, beta. So I have shared the recording of the last day's class. I think you have gone through that. So I think we did the dot product in the last class, no? Dot product.
Yes, sir.
So now we'll do the cross product.
सर क्रॉस प्रोडक्ट भी कर लिया था, उसके 3 केसेस भी कर लिए थे.
Cross product. Okay, good. The resolution of a vector into 3D rectangular component form. I have already explained that in the class, no? So yes, this is also we have done. Product of vector. So in physics at class 11, there will be two types of product of vectors, and they are dot and the scalar product, cross and vector product. We already did this in the last class. Let me explain once again the dot product. Dot product in vector product, the symbol of multiplication between the vectors is represented by cross. So the result of the product is a vector. And previously, when we were dealing with the dot product, the result of two vectors was the scalar, as in case of work done. Whenever there is a work done, it is the dot product of force vector and of displacement vector. And remember one thing, force vector is a polar vector. So any vector which has a point of application, any vector which has a point of application, that is called a polar vector. So force is a polar vector. And now, yes. So torque is defined as the product of force and momentum. So I'll teach you in the systems of particles, that is torque. Actually, torque is nothing but the turning effect. Turning effect. So here force moment and the torque moment are all vectors. So consider two vectors once again, vector A and vector B. Vector A and vector B. The cross or the vector product is given by A cross B. Vector A cross vector B is equal to the product of the magnitude. And here a modulus A. This is the magnitude of vector A, and it is the magnitude of this vector B. So the product of the magnitudes of the vector with the angle of cosine with the angle of sine between them. And in the scalar product, it was the angle of cosine, but in the cross product, it is the angle of sine. And this n cap represents the unit of the third vector, which is the product of A and B. So where n is the unit vector along a direction which is perpendicular to the plane containing A and B, and it is the sine theta is equal to, if we bring the product of magnitude to the bottom of the LHS, and it will become sine theta is equal to the cross product upon the magnitude of the product of the magnitude. Here, it is the magnitude of the cross product in the numerator side, and on the denominator side, it is the product of the magnitude. Here, magnitude of the cross product and product of the individual magnitude. This is the difference here. So A cross B, vector A cross B means vector A is rotating towards vector B, and its effect is taken on B. So vector is being rotated towards vector B. Here we are having vector A, OP is representing vector A, and this OQ representing vector B. So by right hand thumb rule or Maxwell's corkscrew rule, the direction of the resultant in this case is perpendicular and into the plane of the diagram. So these two vectors are kept over a plane. When we multiply A with the B, means when we rotate A towards B, in that case, the third vector that will come into the plane. So vector B cross vector A means that vector B is rotated towards vector A and effect is taken on A, and the resultant in this case is perpendicular and emerging out of the plane of the diagram. Is it clear, students?
Yes, sir.
Okay, please take the screenshot. Take the screenshot quickly. We will do it on the whiteboard as well. Take the screenshot. So example, closing and opening a tap is the best example for the cross product. So when you apply force over the tap in this way, so it will come out of the plane. Vector B is rotated towards vector A. So it will come out and the water begins to flow through the tap. When you close it, that is anti-clockwise, and when you open it, it is a clockwise direction. Okay. So property of the cross product, the vector product results in a vector. So means the output of the vector product is the vector itself. And the vector product or cross product is non-commutative. It means vector, the product of vector A and B is not is equal to of the cross product of vector B and vector A. Means first one, LHS means vector A cross vector B means vector A is being rotated towards vector B. But on the right hand side, the vector B is being rotated towards vector A. So it is not commutative, it is negative. So therefore, I have written here vector A cross vector B is equal to negative of vector B cross vector A. And I cross I, unit vector I cross I, because it is a 0. When you multiply the unit vector of x-axis, that is I cap, or of j cap, that is the unit vector of y-axis, or k cap, that is the unit vector in the direction of z-axis. When you multiply unit vector to itself, so every vector is parallel to itself, so the angle is 0, and sine 0 is 0. So I cross I or j cross j is equal to k cross k. They produces 0 in the cross product. But when you multiply I with j, it produces k, the third vector. Or when you multiply in cross product j with k in cross product, j cap cross k cap, it produces I cap, the third vector in the 3D. Or when you multiply vector k cap cross with vector I cap, then the product will be the j cap. Or if you take in other direction, if you keep vector j first, then after cross vector I, so here it will be negative, applying this non-commutative. Similarly, for the rest of the term, so j into I is equal to negative k cap cross j cap is equal to negative I cap, or I cap cross k cap is equal to negative j cap. And the sixth is it is a vector form in 3D when the particle in the space, so we can represent it with respect to x, y, and z axis. Also, we can multiply the vectors, that is a cross vector, by doing this determinant method or matrix method. So A cross B means ijk is same. Suppose that vector A is equal to ax I cap plus ay j cap plus az k cap. Here ax, ay, and az are the scalars, and I cap, j cap, and k cap are the vector parts and of this form. Huh? So, and similarly, there is another vector, vector B, that is bx I cap means component along the direction of x-axis plus by j cap means the component of this vector B along the direction of y-axis and plus bz cap along the direction of z-axis k cap. So when we multiply A with B in the cross product, so it will be A cross B is equal to, we will make this a determinant, and the common thing in both vector is I, J, K. So I will put once I, once J, and once K on the first row. This is called row. These are called rows. It is row 1, row 2, and row 3. And similarly, we have columns. It is column 1, column 2, and column 3. Column 1, column 2, column 3. So row and column. So 3 row and 3 columns are there. In the first row, we will just plot or just put the which is given in the vector. These are the unit vector ijk. So I will put ijk because ijk common in A and B. Now the first vector is A. So now I will arrange the scalars of A, ax, ay, az. So first row I cap represents, the first column represents the component along the x-axis of both vectors, and the middle column represents the component of y-axis of both vectors, and the third column, that is I cap, represented by I cap, here we will arrange the scalars of both vectors which are in the direction of z-axis. So from vector A, ax, we have put here ax and ay and az. Similarly, from vector B, bx, by, and bz. Now we will multiply it by a special rule. It's a cross product. Okay, it is just like a cross product. So what I did here is equal to for the first element, we are having this first element. This first element. So its row, leave its row and its column. Leave these elements. So you will notice ay, az, by, and bz. So now just put this I cap out of the bracket. So in the bracket, first multiply ay in the cross product, ay with the bz, ay with the bz, minus az with the by, az with the by. So in these elements, first element is taken as positive, the next is negative, then the positive. No two negative or two positive comes together in the order or along the row or along the column. There must be one positive and one negative. So I was the positive. Next J is the negative. I put the negative symbol here. Now what we will do, the row which are associated with the vector j cap and the column, remove these, and you will notice these 4 elements. Now I multiply ay with az, bz, ay, bz, minus now az with by, az with by, and out of the bracket j cap. Now the third element is positive again, so I put a positive symbol. and bracket. The third element is k cap. Now the column and row of third element. Now we are having these four elements. So ax multiplied with by, ax by minus ay bx out of the bracket k. So this is called cross product. It is easy method to produce two vectors in cross product. Easiest method. Huh? So what is the magnitude? The magnitude is same. The magnitude of A cross B under root all the scalar parts of three components of the vector. Means AY minus BZ, AY BZ minus AZ BY ka square plus AY BZ minus AZ BX square plus AX BY minus AY BZ square. So this is the which is called the magnitude of the cross product. Now you can note it or you can take the screenshot. Okay, let's move to the next slide. So it is completed. But so in the first slide, I explain you about vectors, their dot and cross product. Now let's move to the screen whiteboard and understand this concept once again. If the white screen is visible to all of you?
Yes, sir.
Okay.
Yes, sir.
Okay. Students, listen, please respond whenever I ask something, respond. Okay. So once again, dot product, sorry, cross product. Cross product. Suppose that we are having vector A. Let us consider a plane. We are having a plane. Plane is something like a sheet of paper. Let's say we are having this plane and two vectors are there on the plane. Vector B and vector A. It is vector B and here we will put vector A. It is vector A. So both vectors are coplanar vectors. Did I explain? Did I tell about coplanar vector in your class?
Yes, sir.
The
Definition.
vector which are the vectors which are in the same plane. The vectors which are in the same plane are called coplanar vectors. So here A and B are the coplanar vector. They are in the same plane. So when I rotate A towards B, when I rotate A towards B, it is called A cross B. When the A is being rotated towards B, it is called A cross B. So in this case, their product, there is an angle between them, that is angle between vector A and vector B. So when I rotate vector A towards vector B, a third vector, which is the product of these two, a third vector, which is the product of these two, it comes out of the plane. It comes out of the plane when the vector A is rotated towards vector B, then this third vector, which is the product of A and B, comes out of the plane. And how long it is denoted by its unit, that is n cap. So what happens when you multiply or when you rotate B towards A? When you rotate B towards A, in that case, this third vector changes its direction. Now it comes into the plane. Now it comes into the plane. So let's say we are having this third vector and it is denoted by vector C. Vector C is what? Vector C is the cross product of vector A plus B, of vector A plus B. So vector A cross vector B is equal to product of their magnitude. So what is the product of vector A? The magnitude of vector A is A. The magnitude of vector B is B. AB with the angle of sine between them using this theta, applying sine theta. Now this vector, that is third vector, having some units, how long it is. So we denote it by n cap. So it will be unit vector n cap here. N cap. So it is when A is being rotated towards B. So it is called cross product. So let us define it. The product of the magnitude of two vectors vector A and vector B with the angle of sine means sine theta. With the angle of sine between them is called cross product. It is called cross product. Product is also a vector. So the third is the vector. The product is C. C is also a vector. So it has three cases. Now let us take one more example in opposite order. We are having one more plane this time. Let's say this is one more plane. And in this plane, once again, let us keep two more vectors. Vector A this side and vector B. It is vector A now. We interchange the position of vector, and here it is the position of vector B. When the B is rotated towards A, Now, when the B is rotated towards A, in that case, the third vector, that's coming into the plane. So now the C is in opposite direction. So this is the angle. Now rotation is from B to A. So this is C here again, but C is B cross A. B cross A, same sine theta n cap, but B cross A in the sense means negative of AB sine theta n cap, because the direction is opposite. In the previous case, it was pointing toward in upward direction, and here it is in downward direction, in opposite direction. So we can say if it is vector C, let's say vector A is cross multiplied with vector B, then this is the direction of vector C. But what happens when we multiply with B, B with A? First, we will take B, then we will take A. In that case, now it is vector B cross vector A. The order is changed. So the direction of C is this. So magnitude remains the same in both the cases. The magnitude is same, but direction becomes opposite. So here C is negative. Please take the screenshot. I'm changing the slide. Okay. Now, how to multiply these vectors? Let us consider three cases. Case 1. When vector A is parallel with vector B. In that case, angle between them is 0 degree. So we will say vector A is parallel with vector B, then their cross product will be AB sine theta, and the theta is 0. Because the value of sine 0 is 0. So the cross product of AB will be AB into 0. So it will be 0. Next case, when the vector A is moving toward right side, and vector B towards left in the opposite direction, and this is the angle between them, that is angle of pi. So these are called anti-parallel vectors or opposite vectors. Theta is 180 or pi radian. In that case, sine 180 degree is 0. So same value is there, na? As it was of sine 0 was producing 0, sine 180 is also 0. So the product will be the same. In that case also, vector A cross vector B will be 0. So in these two cases, the vector product is 0. Now the third case, when vector A and vector B are mutually perpendicular, it means theta is equal to pi by 2 radians, or we can say 90 degree. So the value of sine 90 degree is maximum, and the maximum value of sine is 1, and the minimum value of sine is -1. So it is 1. So vector A cross vector B is equal to AB sine 0. Sine 90. Sine 90, so it will be maximum. AB into 1, so this will be maximum. So these are the three cases. Please take the screenshot. Take the screenshot, please. Student, I asked you to respond, yeah. At least you should reply now if you have taken the screenshot.
Yes, sir, I have taken.
Okay.
Yes,
All of you
sir.
should reply. Okay. So it is less than 1 minute remaining in the class. Please quickly rejoin. Please quickly rejoin the class with the same link. I'm restarting the class. Quickly rejoin.